Picture this, okay? It's June 1802.
Right.
And you are 19,000 feet up the side of Mount Chimborazo.
A completely dormant volcano down in the Andes of Ecuador.
Exactly. And the air is so incredibly thin that your gums have actually started to bleed.
Oh, yeah, that's brutal.
Your boots are shredded, your lips are totally cracked, and you are gripped by this terrifying, just suffocating dizziness. The local guides actually call it cirrhosis.
Mountain sickness.
Right. And by all rational measures, you should be focused entirely on just getting down the mountain so you don't die.
Yeah, survival should be the only priority.
But instead, you are crouched in this freezing wind, painstakingly trying to read the mercury level inside a really fragile 3-foot-long glass tube without dropping it.
Which is just wild to think about.
It is. And you're doing this while simultaneously taking notes on, like, the specific species of lichen that are clinging to the rocks right at your boots.
It's this image of absolute, just obsessive dedication. I mean, he's bleeding, he's freezing, and his primary concern is getting a data point.
And not just any data point, right? A data point that would fundamentally change how we understand the entire planet.
Absolutely.
You know, usually when we talk about a diagnosis, whether it's medical or mechanical, there's this expectation of precision.
Right. A clear answer.
Like, you break your arm, the x-ray shows that jagged white line, and the doctor just points and says, you know, there it is, that's the problem. It's binary, it's clean.
We really like things to be visible and categorized.
Yeah.
You know, the universe just broken down into neat little boxes.
But when you step back and try to understand our entire planet, especially if we are talking about the intellectual landscape before the 19th century, that x-ray machine just doesn't exist.
Not at all.
You're looking at a scientific landscape that is, honestly, it's completely murky.
Oh, it was a definition of diagnostic muddy waters.
Mm-hmm.
I mean, geography back then wasn't really a science.
It was mostly just guessing.
Basically, yeah.
Yeah.
It was this chaotic blend of sailors' tall tales, theological assumptions, and highly fragmented, localized descriptions.
A weird travel brochure.
Right. There was absolutely no unifying theory tying, say, the shape of a coastline to the plants that grew on it.
Which brings us to our deep dive for today. And welcome to you, the listener. We know exactly why you are here.
You're the learner.
Exactly. You're looking for that thorough, engaging mastery of a complex topic without, drowning in information overload.
We respect your time.
We do. And today we are looking at the foundational diagnosis of the Earth itself. We are exploring the life and the mind of the man who essentially built the very first working X-ray machine for our planet's ecosystems.
Alexander von Humboldt lived from 1769 to 1859.
The ultimate polymath.
Truly, an 18th century Prussian aristocrat who essentially served as the founding father of modern geography.
And he took those disjointed myths you mentioned and turned them into a rigorous analytical science.
He really did.
And what we are going to do today, pulling from a massive stack of sources, including comprehensive excerpts on the history of geographical thought, detailed biographical notes on his expeditions, and his core scientific philosophies, is track how the single individual proved that absolutely everything in nature is connected.
Which was a radical idea at the time.
It's insanely radical. I mean, long before modern climate science, this guy was out in the wild figuring out human-induced climate change.
In the early 1800s.
We're talking about the early 1800s. He's like an 18th century Indiana Jones, but, armed with the mindset of a modern data-obsessed systems analyst.
That combination is really what makes him so revolutionary.
Yeah.
He didn't just theorize from a desk.
Right.
He brought empirical, relentless observation into some of the most dangerous environments on Earth.
So let's figure out how someone actually develops that kind of mindset. Because you don't just wake up one day and decide to invent modern geography while hauling heavy brass instruments up a volcano.
No, it takes a very specific kind of upbringing.
Right. So he was born in Berlin in 1769. This is a very aristocratic Prussian family.
Very wealthy, very connected.
His father is actually an officer in the Prussian army, but he dies when Alexander is only 10 years old.
Yeah. And that loss left Alexander and his older brother under the very strict guardianship of their mother.
And she had some pretty intense plans for them, right?
Oh, absolutely. She was determined to mold them into elite Prussian civil servants.
No pressure there.
None at all. She provided the absolute best private tutors available at their family estate in Tegel, which is near Berlin.
So we are talking about a childhood dominated by rigorous instruction in classical languages, economics, finance, history, technology, and advanced mathematics.
Just a completely overwhelming amount of information.
That is a tremendously heavy intellectual load for a kid. It sounds incredibly isolating, honestly, just being like hot-housed for government service.
It was highly isolating.
Yeah.
But, it also forged a mind that was capable of absorbing and retaining vast, disparate amounts of information.
I guess you'd have to survive that curriculum.
Right. And he eventually moved on to university education, spending time at Frankfurt, and then the University of Göttingen.
And Göttingen is really where the spark catches. Like, the sources highlight a highly pivotal meeting there around 1789.
Yes.
He crosses paths with a man named George Forster.
George Forster is just a crucial catalyst in the Humboldt story.
Tell me about him, because he seems fascinating.
He is. Forster had actually sailed the uncharted oceans of the world. He accompanied his father, Johann Reinhold Forster, on Captain James Cook's second voyage around the globe.
Okay, just pause and imagine that. You are a university student, you are stuck in this rigid Prussian academia, and your new hiking buddy is a guy who has literally sailed to the edges of the known world with Captain Cook.
The stories he must have told him.
I mean, it must have blown his mind.
And it wasn't just adventure stories, though. The Forsters were highly critical of the way science was conducted back in Europe at the time.
Why? What were they doing wrong?
Well, the elder Forster had famously complained that European scholars were just collecting random exotic facts from all over the world without any underlying system.
Just hoarding trivia.
Exactly. He called the prevailing scientific knowledge and this is a great quote, a confused heap of disjointed limbs.
Wow. A confused heap of disjointed limbs. So it's basically a cabinet of curiosities rather than an actual functioning understanding of nature.
That's perfectly put. And George Forster shared that exact frustration, and he passed it right on to Humboldt.
When they were hiking, right?
Yeah, when they took a long hiking trip down the Rhine River together, Forster basically infected the young Humboldt with a radical new passion.
Which was?
The absolute necessity of empirical comparative field observation.
Meaning you have to actually leave your house to understand the world?
You have to get out of the armchair. I mean, you cannot understand how the phenomena of nature relate to each other if you are just examining a dried leaf sent to you in a wooden box.
Right, because it's totally stripped of its context.
Exactly. You have to see the leaf, you have to see the soil it grows in, the angle of the sun hitting it, and the moisture in the air surrounding it.
That makes perfect sense to us now, right? But back then, his mother still held the purse strings, and she had very different plans.
She certainly did.
She actually sends him to a commerce academy in Hamburg to study finance.
Which he hated.
Oh, clearly. Though, reading between the lines of the biographical sources, he was clearly sneaking around to study botany and mineralogy on the side.
He was a terrible finance student,
But,
a great rogue botanist.
Eventually, he goes to the Freiburg Academy of Mines to study under this incredibly famous geologist named A.G. Werner.
Yes, Werner was a total giant in geology at the time.
And he had a very specific theory, right?
He did. He championed a theory known as Neptunism.
Neptunism. Like the ocean god?
Right. It was a belief that all rocks on Earth were of sedimentary origin, essentially deposited by a primeval ocean.
Everything came from the water settling.
That was the idea. And we will see Humboldt spectacularly disprove his own teacher later on. But at this point, Humboldt is just a diligent student absorbing everything he can about the subterranean world.
Diligent enough that he actually gets a real proper job.
Yeah.
From 1792 to 1796, he works as a director of mines in Prussia.
And he's fantastic at it.
He really is. He climbs the corporate ladder of the 18th century mining industry. He improves efficiency. He invents safety equipment for the miners. And he successfully manages the state's resources.
He was totally set for life.
But then, in 1796, his mother dies.
Yes.
And he inherits a massive fortune.
A very substantial inheritance that immediately alters the trajectory of scientific history.
I mean, he essentially had this cushy, high-level corporate gig, but the little second the inheritance clears, he just quits.
Instantly.
He takes his own money to become a self-funded rogue explorer. It's like a tech CEO taking a massive buyout and immediately abandoning Silicon Valley to go count beetles in the Amazon.
It's a completely wild pivot.
It seems so erratic.
It does seem erratic until you look at the papers he was actually publishing while he was still working in those mines.
Oh, he was writing back then.
Oh, yeah. He wasn't just managing the extraction of minerals. He was constantly observing everything around him. In 1793, he published a Latin text called Florae Freibergensis,
which means...
It was a study of the subterranean plants growing down in the dark shafts of the Freiberg mines.
Wait, plants growing underground without sunlight?
Yes. And he wasn't just classifying their anatomy, which is what traditional botany did back then.
Right, counting the petals and leaves.
Exactly. He was studying these plants in relation to their highly unusual environment.
Oh, looking at the whole picture.
Right. How did the lack of light, the specific humidity of the mine, and the surrounding rocks dictate the survival of these specific organisms?
So he's looking at the system.
Yes, he was laying the very earliest groundwork for what we now call biogeography or plant geography.
He's already starting to connect the dots. Because the sources mention, he wrote, that while botany studies the mere anatomy of a plant, plant geography traces the connections by which all plants are bound together and to their land.
He was already rebelling against the compartmentalization of science.
People wanted to keep things separate.
They did. Knowledge was being endlessly parceled out into separate, isolated domains. Botany here, geology over there. Humboldt's radical idea was that the boundaries between these domains were completely artificial.
So he's got this radical idea, he's got an endless curiosity, and now he has the massive financial resources to test his theories on a global scale.
He's got the bankroll.
Exactly. So how does he do it? He buys the most advanced, notoriously heavy scientific instruments of the age. He somehow gets special permission from the King of Spain to travel, and he points his compass toward the most extreme environments he can access.
Which takes us straight to the legendary Latin American expedition.
This is the big one.
It is. This journey lasted from 1799 to 1804. And he didn't go alone, by the way. He teamed up with a brilliant French botanist named Aimé Bonpland.
And together, they traveled over 4,000 miles across South America.
4,000 miles in the late 1700s.
And the logistics of this are just staggering to me. They didn't just pack a few notebooks and some camping gear. They essentially brought a mobile laboratory into the jungle.
Oh, they were heavily burdened with gear.
The sources list sextants, telescopes, standard barometers, aneroid barometers, and something called a cyanometer.
Oh, the cyanometer.
I have to ask you to explain the cyanometer because when I read that in the sources, it sounded completely absurd. What is it?
A cyanometer is an instrument specifically designed to measure the exact blueness of the sky.
The blueness.
Yes. It's essentially a ring of paper swatches painted in graduated shades of blue, from practically white all the way to deep indigo. You just hold it up against the sky to match the color.
Okay, so he is hauling this delicate painted color wheel through dense, uncharted jungle just to measure exactly how blue the sky is on a random Tuesday.
That's right.
Why? What does the blue of the sky actually tell a geographer?
Well, to a mind like Humboldt's, there is no such thing as isolated trivia.
Right, everything connects.
Exactly. The exact shade of blue indicates the level of atmospheric purity. It tells you about the amount of water vapor suspended in the air, the way light is scattering off microscopic particles.
Oh, so it's a humidity gauge.
In a way.
Hmm.
And the humidity and the light dictate the climate, and the climate dictates what plants can survive there, and the plants dictate what animals thrive, and all that dictates what kind of agriculture human beings can actually sustain in that specific valley.
Wait, so the blueness of the sky is literally a data point about human survival.
Precisely. The blueness is a symptom of the entire ecological engine working together.
Wow. And they test this engine in some of the most brutal conditions imaginable. I mean, let's look at the Orinoco River.
That was a harrowing leg of the journey.
They head deep into the Venezuelan interior to map the Orinoco, specifically to prove a rumor that it physically connects to the Amazon River basin.
Yes. And the conditions on this leg of the journey were horrific.
The sources are quite explicit about that.
They really are. They were navigating dense, flooded river networks that were just plagued by swarms of equatorial mosquitoes and biting ants.
Sounds miserable.
And dangerous. They had to constantly guard against crocodiles and rivers teeming with aggressive carnivorous fish.
And what were they eating?
They were frequently surviving just by eating whatever wild fruits they could forage and whatever fish they could manage to catch.
And amidst all of that, I mean, dodging crocodiles and basically starving, Humboldt is out there setting up his telescopes to establish exact latitudes and longitudes.
Every single day.
He is taking meticulous temperature and magnetic readings. He's treating this wild, deadly jungle like a perfectly controlled laboratory.
Because he knows that if he stops taking the data, the connection is lost.
The whole theory falls apart.
Exactly. And he successfully proved the physical connection between the Orinoco and Amazon basins, navigating the Cassiquiare Canal. But the sheer discipline required to maintain his scientific rigor under those physical threats is really what separates him from mere adventurers.
Anyone else would have just tried to survive. He's taking notes.
Exactly.
But the real turning point of this expedition, the moment that I think really solidifies his absolute genius for the listener, happens at Lake Valencia in Venezuela.
Oh, this is such a crucial moment.
I read this part of the notes 3 times because it felt so unbelievably modern.
It is arguably one of the most prophetic moments in the history of science.
So he arrives at this beautiful lake, and he talks to the locals, and he observes that the water level is rapidly shrinking.
Yes, the banks are flattening out, exposing more land.
Now, the local reaction at the time was simply, oh, great, more flat land. Let's just turn it into agricultural fields.
Very pragmatic.
Right. But Humboldt scales back and looks at the macro picture. He sees that the surrounding hillsides and all the neighboring lands have been entirely deforested by settlers clearing land for cash crops.
He connects the action on the hills to the consequence in the valley.
And what does he conclude?
He established a positive relationship between the deforestation and the reduced rainfall that was starving the lake.
But how does he prove that link in the year 1800?
He essentially deduced the mechanisms of what we now call the water cycle and microclimates.
Just by looking at it.
By observing the connections, he realized that a forest isn't just a collection of wood waiting to be cut. The canopy shields the soil from direct sunlight, which prevents rapid evaporation.
Makes sense.
And the complex root systems act like a giant sponge, holding onto water and releasing it slowly. Furthermore, trees release water vapor back into the air through transpiration, which directly contributes to local cloud formation and rainfall.
So when you chop down the trees to plant shallow-rooted crops, the sun bakes the soil, the water runs off immediately, the local atmosphere completely dries out, and the lake shrinks.
You've broken the cycle. He was the very first scientist to use empirical field data to demonstrate human-induced climate alteration.
That is staggering.
He showed that when humans manipulate one major variable like forest cover, they disrupt the entire localized climate system.
He discovered anthropogenic climate change over 2 centuries ago, just standing in the mud in Venezuela.
Incredible.
He didn't need a supercomputer to model it. He just had to actually look at how the systems interacted.
It is the ultimate vindication of his method, because armchair geographers back in Europe could never, ever have deduced that relationship just by reading detached reports.
You can't see the big picture from a desk.
No, it required standing in the deforested hills and manually measuring the evaporation at the lake.
Which makes his next destination even more insane. They leave Venezuela, they go to Ecuador, and in 1802 they decide to climb Mount Chimborazo.
Which was widely believed to be the highest mountain peak in the entire world at the time.
And this brings us right back to that visceral image we started with. They climbed to 19,286 feet.
It was a world altitude record that stood for decades.
And he isn't just climbing for glory like a mountaineer. He is essentially turning his own body into a scientific instrument.
Yes, he is observing the physiological effects of extreme altitude firsthand.
The locals called it cirrhosis, right, mountain sickness.
Exactly. And before Humboldt, mountain sickness was treated as this mysterious affliction. People thought perhaps it was caused by toxic exhalations from the rocks or maybe spiritual anger.
Like the mountain was cursing them.
Right. But Humboldt was the first to provide a medical atmospheric explanation for it.
How did he figure it out while he was half dead up there?
By watching his barometer.
The glass tube?
Yes. He knew that the barometer measures atmospheric pressure, the literal weight of the air pushing down on the Earth. As they climbed higher and the mercury in the glass tube dropped lower and lower, he realized the air was fundamentally thinning.
The weight was lifting.
Exactly. And less pressure meant less oxygen in every single breath. He deduced that cirrhosis was simply hypoxia, the body starving for oxygen due to low atmospheric pressure.
So simple once you have the data.
And while he's suffocating from hypoxia, he is also visually mapping the entire mountain.
Oh, right. The plants.
He documented the vertical zones of the Andes. He noticed that as you move up the mountain, the temperature drops in a highly predictable way, and the plant life changes to match it perfectly.
He created a famous illustration of this, didn't he?
He did. It's called the Natuurgemälde. It's a cross-section of the mountain where he mapped exactly which plants grew at which specific altitudes.
And what did it show?
He showed that a journey up a mountain at the equator effectively simulates a journey from the equator all the way to the Arctic poles.
Oh, because it gets colder the higher you go?
Exactly. The lush tropical plants at the base give way to temperate oaks, which give way to alpine shrubs, which give way to lichen and eventually just snow.
He's showing that altitude, temperature, and vegetation are all just locked together in this global mathematical dance.
That's a great way to put it.
And if you understand the math, you know exactly what kind of human agriculture can survive at what elevation anywhere in the world.
The synthesis is just breathtaking. And he applied the exact same rigor when they descended from the Andes and reached the coast of Peru.
He didn't just look at the land. He turned his thermometers to the ocean.
Yes.
He literally wades into the Pacific Ocean and measures the temperature and velocity of this massive, cold current running up the coast.
But everyone now called it the Humboldt current.
Right, though the sources note he modestly just called it the Peruvian current.
Typical Humboldt. But by measuring that cold water, he actually explained the arid desert climate of the Peruvian coast.
How does cold water make a desert?
Well, cold water doesn't evaporate as easily as warm water, and that means fewer clouds form over the ocean.
Which means no rain.
Precisely. It results in practically no rainfall on the adjacent land. The ocean current creates the desert.
Everything is connected. The ocean dictates the desert, and the desert dictates what can live there, which leads him to his next massive discovery on that coast.
Yes.
Bird droppings.
Guano.
He finds these islands off the coast that are just covered in massive ancient mountains of guano. But because he understands chemistry and agriculture, he realizes this isn't just a weird curiosity.
No, he realizes it is an incredibly potent fertilizer. It's rich in nitrogen and phosphorus.
Because of the fish.
Exactly. The cold current sustains massive fish populations, which sustain massive seabird populations, which leave centuries of guano perfectly preserved.
Preserved because it never rains, because of the cold water.
You see how it all hangs together?
It's brilliant, and he takes samples of this guano, sends it back to Europe, and mathematically proves its agricultural value.
He literally initiates the commercial export of guano.
Which completely transforms and revitalizes depleted European farmlands. Like, he went to South America to study nature and ended up saving European agriculture by accident.
It's quite a legacy.
Yeah.
But the crucial takeaway from the Latin American expedition isn't just the guano or the altitude record or the discovery of the Orinoco's path.
What is it then?
It is what he did with all that raw data when he finally returned. Humboldt used those thousands of isolated data points to formulate a completely new philosophy of science.
This is where we need to dig into the philosophical mechanics of his mind. How do you take a bunch of thermometer readings and turn them into a worldview?
Well, it starts with his absolute reliance on the inductive method.
The inductive method, that's bottom-up reasoning, right?
Exactly. Imagine trying to figure out how to bake a cake. The deductive method, which was how a lot of philosophy and science was done at the time, would be to start with a grand, abstract theory of what a cake should be.
Like a cake must be perfectly round and sweet.
Right. And then you try to force whatever ingredients you have into that preconceived mold. You start with a law, and you try to make the facts fit the law.
So, the universe is perfectly symmetrical, therefore this coastline must be a straight line, even if you can plainly see it isn't.
Precisely. It was top-down. But Humboldt completely inverted that. The inductive method means you start with absolutely no assumptions.
A blank slate.
Yes. You go out and carefully collect the raw ingredients, the empirical data, that specific field observations. You reverse engineer reality.
You gather thousands of temperature readings, plant locations, and pressure metrics, and you just lay them all out on the table.
And you wait for the data to reveal the general laws of nature to you.
And when he laid all his data out from South America, the overarching law that revealed itself to him was a concept he called Zusammenhang.
Yes, Zusammenhang. It's a German word that translates beautifully to hanging together.
Hanging together. It's honestly my favorite concept from this entire deep dive. It sounds kind of folksy, but it is a profoundly rigorous scientific assertion.
It really is.
He proved mathematically that there is a harmonious, interdependent relationship between the organic world, the living plants and animals, and the inorganic world.
The dead rocks, the invisible air pressure, the ocean currents.
Everything is hanging together in this delicate, shifting web.
And we take this for granted now, right? But you have to understand how radical a rejection this was of the prevailing scientific worldview.
Because before this, how did they see it?
Since the days of Descartes and Newton, the dominant paradigm was the mechanistic view. Nature was seen as a giant, dead, clockwork machine.
Just cogs turning.
Right, a collection of disconnected passive parts that you could take apart and study in complete isolation.
But Humboldt says no, you can't take the clock apart because the gears are actually alive and they're constantly changing each other.
Yes.
A forest creates rain, and rain creates a forest. You literally can't separate them without breaking the truth of what they are.
And crucially, he studied this web of connections purely scientifically. The sources emphasize his scientific materialism.
Meaning he kept religion out of it.
Exactly. He approached the Earth strictly secularly. In all of his monumental writings on the cosmos and nature, he deliberately never used the word God.
His goal was to explain the mechanisms of nature without ever appealing to religious dogma or supernatural intervention.
Just the math and the physical laws.
Which brings us to a really fascinating historical contrast in the sources. If we want to understand how unique Humboldt's worldview was, the notes tell us to look directly at the other founding father of modern geography.
His contemporary, Carl Ritter.
Carl Ritter, he is an unavoidable figure in this story.
He really is. He and Humboldt are universally acclaimed side by side as the twin pillars who elevated geography into a modern science.
They both realized that geography couldn't just be a descriptive list of places, right?
Right. They both agreed it had to be a systematic analysis of causal relationships.
But they arrived at that conclusion from entirely different universes.
Yeah.
We talked about how Humboldt used the inductive bottom-up method. The sources highlight that Ritter used a deductive teleological approach.
Let's define teleological for the listener quickly.
Yeah, go ahead.
A teleological approach attempts to explain events or phenomena not by their physical causes, but by the purpose or goal they are meant to serve.
The ultimate why.
Right. Ritter believed that the Earth was a divinely ordered environment. He believed God specifically designed the planet to facilitate the progress and education of mankind.
So he looked at the shape of the continents and saw a divine architectural blueprint for humanity.
Exactly. Ritter's geography was deeply anthropocentric and theological. He famously wrote, let me think. As the body is made for the soul, so is the physical globe made for mankind.
Wow, that is a completely different starting point.
He believed you could deduce God's plan for humanity just by studying the physical arrangement of the earth. His harmony was a divinity-centered harmony.
Whereas Humboldt's harmony was built purely on scientific materialism and the hard physics of Zusammenhang.
Completely secular.
And the historical irony of this dynamic is almost too perfect for fiction. I mean, Humboldt and Ritter lived in the exact same city, Berlin, for over 30 years.
They practically invented the discipline of modern geography together.
And they both died in the exact same year, 1859. Yet, one looks at a mountain and sees the fingerprints of God guiding human destiny, and the other looks at the exact same mountain and sees the physical interaction of barometric pressure in plant biology.
It's amazing. And despite this profound philosophical chasm, they deeply respected one another.
They didn't hate each other.
Not at all. Ritter frequently acknowledged Humboldt as his teacher. He openly admitted that his own massive geographical volumes could never have been written without the vast amounts of comparative empirical data that Humboldt had dragged out of the jungle.
So Humboldt provides the raw, secular data that proves everything is connected.
Yes.
How does this reframe the broader scientific philosophy of the era? The sources mention the philosopher Immanuel Kant.
Right. So decades earlier, Immanuel Kant had tried to philosophically justify and organize human knowledge.
Yeah.
Kant suggested that sciences could be classified not just logically, like, physics grouping rules of matter or chemistry grouping elements, but physically, by time and space.
How do you classify a science by time and space? That sounds super abstract.
Well, Kant argued that history is the science of time. It is chronology. It studies phenomena as they happen in sequence.
Okay, that tracks.
And geography, Kant argued, is the science of space. He called it chorology.
So chorology.
Yes. It is the study of how phenomena are arranged together on the surface of the Earth at a given moment in space.
Looking at how things share space. But
Yeah.
Kant was a philosopher. He was just dealing in abstract concepts.
Exactly. Humboldt is the one who took Kant's abstract chorology and actually injected it with thousands of hard data points.
He proved it.
He mathematically proved the chorological reality. You cannot fully understand the biology of a plant without understanding the climatology of its space, and you cannot understand the climatology without understanding the geological altitude.
He took Kant's philosophical space and filled it with a vibrant, interconnected ecosystem.
He made it real.
He essentially proved the hanging together in the real world. Now, having established this incredible philosophy based on his time in the tropics, Humboldt doesn't just retire to a library.
No, of course not.
Decades later, As an older man, he decides to apply this unified lens to a completely different frozen environment.
Which takes us to 1829. Alexander von Humboldt is now 60 years old.
Which was quite old back then.
Very old for an explorer. But he receives a highly lucrative invitation from the Russian Tsar. The Tsar wants Humboldt to explore the vast, untapped virgin lands of Siberia.
60 years old, and he just hops into a horse-drawn carriage to travel across the brutal Ural Mountains, pushing all the way to the borders of Mongolia.
And true to his nature, age has not slowed his obsession with data one bit. He is meticulously recording the temperature, the barometric pressure, the magnetic variations, and the rock formations every single step of the journey across the Russian expanse.
Just relentless. And based on the massive amount of meteorological data he collected on this trip, he gives the Tsar a very specific piece of advice, right?
He does. He tells the Russian government they need to set up a permanent network of meteorological stations stretching across the entire empire to track the weather systems over time.
And that advice catalyzed a massive leap forward in global climatology. Because Humboldt didn't just collect this Russian data, he combined it with the data he took in South America and the data he had from Europe, and he basically invented a completely new way of visualizing the world.
Yes, he drew the world's very first map using isotherms.
Isotherms. Let's break down how revolutionary this is for the listener, because today we open a weather app on our phones and we see those colorful bands of heat and cold sweeping across a map, and we just take it completely for granted.
An isotherm is a line drawn on a map connecting points on the Earth's surface that share the exact same average temperature.
And before Humboldt did this, what was the general assumption?
People generally thought that latitude was destiny. They assumed that if two cities were on the same horizontal line on a map, the same distance from the equator, they must have the exact same climate.
But Humboldt's thousands of thermometer readings proved that wasn't true at all.
Not even close. When he plotted his data points and drew the lines connecting equal temperatures, the lines weren't straight, horizontal bands. They dipped wildly south and curved dramatically north. They were wavy and incredibly complex.
Why do they wave? Like, what causes the deviation from the latitude line?
Well, that question led Humboldt to establish the concept of continentality.
Continentality.
He realized that land and water absorb and release heat at very different rates. The specific heat of the ocean allows it to moderate the temperature of the air above it.
So coastal areas have milder winters and cooler summers.
Exactly. But as you move deep into the interior of a massive landmass like Russia, far, far away from the moderating influence of the ocean, the climate becomes extreme.
Blistering summers and incredibly brutal winters.
Right. He proved mathematically how being far from the ocean alters the fundamental climate of a region, regardless of its latitude.
And while he was out there freezing in the Russian interior, studying this extreme climate, he coined a term that is absolutely central to modern climate discussions.
Permafrost.
He used it to scientifically explain the permanently frozen deep layers of Siberian soil.
But he wasn't just looking at the weather in Russia. The Siberian expedition also allowed him to finalize a major geological debate.
Oh, this is where he dunks on his old teacher.
Exactly. He looked very closely at the crystalline rock formations in the Ural Mountains.
And this is where he finally, definitively takes down A.G. Werner.
Werner, as we recall, was a Neptunist. He believed that even hard, crystalline rocks like granite and gneiss were formed by sediments settling out of an ancient global ocean.
But Humboldt, having seen the massive volcanoes of the Andes and now examining the deep structure of the Urals, proves that Werner was entirely wrong.
Humboldt proved the Plutonist view.
Which means?
He demonstrated that granites and igneous rocks were actually formed from molten, superheated material erupting from deep within the Earth's interior and cooling over time.
So the Earth wasn't shaped just by water, it was fundamentally shaped by internal fire.
Exactly.
So he maps the temperatures, he defines permafrost, he solves the origin of rocks. But here is where Humboldt's genius reaches, I think, its most profound level.
The human element.
Yes. He doesn't just apply the concept of Zusammenhang to rocks and plants. The sources are extremely clear about this. Humboldt included human beings as an integral, inescapable part of the natural landscape.
To understand this, we have to look back at the research he compiled on his earlier travels through Mexico, which was then New Spain, and the island of Cuba.
Right.
When he evaluated these regions, he didn't just study the exotic botany. He dove deeply into their demographic records, their census data, their agricultural yields, and their economic statistics.
And just to clarify for the listener, according to the sources, we aren't taking a political stance here. We are strictly reporting on the impartial data that Humboldt collected and analyzed. Right?
Absolutely. He was acting strictly as an analytical data scientist, looking at raw numbers.
Right. And his study of Mexico is literally considered one of the world's first true regional economic geographies. He mapped out all the administrative divisions of the country, and he cross-referenced the physical relief of the land and the climate with the exact distribution of the population and the specific crops they were cultivating.
He was charting how the physical geography dictated the economic reality of the people living there. But he didn't stop at mere observation. He used this raw statistical data to highlight severe systemic social injustices.
This is where he essentially invents what we would today call data journalism. He is using raw census data to map out massive wealth inequality and the sheer brutality of human slavery.
He applied the exact same systemic logic to human society that he applied to plant survival.
Let's look at his analysis of Cuba as an example.
Okay, so he examined the stark demographic numbers. He noted that roughly 83% of the island's population were people of color, and that a staggering 50% of the total population were actively enslaved people forced to work the sugar plantations.
So he runs the numbers on this plantation economy. He looks at a tiny fraction of the population hoarding all the wealth and power by brutally exploiting the vast majority of the human beings on the island. And his conclusion, again, is purely analytical.
Right. He wrote a stark warning based on the math. He stated that if the social and economic conditions of the enslaved and marginalized people did not change, political power would inevitably, violently shift to the massive majority who actually possess the physical strength to work the land.
The sources say he predicted a bloody catastrophe as the necessary, unavoidable consequence of that demographic and economic pressure.
It's pure Zusammenhang. Just as altitude strictly dictates which plants can survive on a mountain, economic structures and massive inequality dictate human survival and societal stability.
You cannot separate the human being from the landscape they inhabit. If you exploit the system too hard, the system inevitably snaps.
He saw human society, politics, and economics as different chapters of the exact same geographical book. Nature and humanity were bound by the same overarching laws of cause and effect.
It's all one interconnected system. And as he entered the final decades of his really long life, Humboldt decided it was time to actually sit down and write that book in its entirety, to put all the pieces of the universe together on a single page.
Which brings us to his ultimate legacy and his absolute magnum opus.
Because after the Latin American expedition, Humboldt had lived in Paris for over 20 years to meticulously write and publish his staggering 30-volume account of his American travels.
Voyage aux régions équinoxiales du Nouveau Continent.
Exactly. But eventually, in 1827, he returned home to Berlin. And he spent the final years of his life writing the project that would truly define his legacy. It's simply called Cosmos.
Cosmos, published between 1845 and 1862, was a monumental 5-volume masterwork.
5 volumes.
Yes. Its explicit, almost impossibly ambitious aim was to develop a unified, universal science. He wanted to synthesize absolutely everything humanity knew to provide a scientifically accurate, emotionally resonant picture of the entire structure of the universe.
And in this work, he actually coined the term cosmography, right?
He did. He divided this new superscience into 2 interconnected branches. First, there was uranography, which was descriptive astronomy, dealing with celestial space, the stars, the planets.
Everything out there.
Exactly. And second, there was geography, dealing with the physical reality of the Earth itself.
Let's look at how he structured this massive synthesis. Volume 1 was a grand, sweeping presentation of the physical universe as a whole. But Volume 2 is where his holistic genius truly shines.
Volume 2 is wild to think about from a modern scientific perspective.
Because it looked at nature's portrayal through the ages by landscape painters and poets.
Which you wouldn't expect in a science book today.
Not at all. But he genuinely believed that human emotion, art, and aesthetic appreciation were vital, necessary components of understanding the universe.
To Humboldt, a poet's emotional reaction to a sunset was just as much a part of the cosmos as the atmospheric refraction of light causing the colors.
You needed both the data and the poetry to capture the truth of Zusammenhang.
It's a beautiful way of looking at it. Volume 3 tackled the hard physics of astronomy. Volume 4 zeroed in on the Earth, treating humanity as an inseparable part of the planetary system.
What about the 5th one?
The final fifth volume was intended to dive even deeper into the specifics of plant and animal geography, but sadly, Humboldt died in 1859 before he could complete it.
Still, the impact of Cosmos was just unprecedented. It was a massive global bestseller. It was translated into nearly every major language and deeply inspired the entire next generation of scientific minds.
And no mind was more inspired than that of a young British naturalist named Charles Darwin.
Darwin literally carried Humboldt's personal narratives with him aboard the HMS Beagle.
He said reading Humboldt changed the course of his entire life.
And there's a profoundly poignant date we need to highlight here from the sources. Charles Darwin's On the Origin of Species was published in 1859.
The exact same year Alexander von Humboldt died.
It feels like the ultimate passing of the torch in the history of science. Humboldt spent a lifetime proving the interconnectedness of all living things through geography, and on the very year he passes away, Darwin steps forward and provides the biological evolutionary mechanism that explains exactly why they're connected.
It is a beautiful continuity. But what happens next in the history of science is actually quite tragic.
Yeah, looking through the sources, the final notes on his legacy carry a real sense of melancholy. Humboldt achieves this beautiful, unified view of the universe. He proves that everything hangs together, but almost immediately after his death, the scientific world completely fractures.
It fractured into hyper-specialized silos. The late 19th century saw a dramatic shift in the scientific method. Physics and chemistry became the dominant, prestigious models for how science should be done.
And those sciences favored reductionism.
Right, breaking things apart.
To understand the whole, you have to break it down to its smallest piece.
Yes. To be considered rigorously scientific in the decades after Humboldt, you had to isolate variables. You had to drag a single subject into a sterile laboratory, strip away all its environmental context, and study it in a vacuum.
So the biologists stopped talking to the geologists, and the geologists stopped talking to the meteorologists.
Which is the absolute antithesis of Zusammenhang.
The sources explicitly note that geography faced a massive crisis of identity following the deaths of Humboldt and Ritter.
Because geography, by its very nature, studies the messy, overlapping reality of everything existing together. It couldn't isolate a single variable, so it was seen as less rigorous.
Humboldt's holistic approach fell completely out of fashion for decades.
Science basically forgot the forest because it was obsessively staring at individual bark cells through a microscope.
But the sources also point out his ultimate vindication, right? It took nearly a century. But with the rise of the modern environmental and ecological movements in the mid-20th century, the scientific community collectively realized that Humboldt had been right all along.
You cannot study a complex system by isolating its parts.
You can't understand a dying lake just by looking at a cup of its water in a lab. You have to look at the trees on the hill, the rainfall, and the farmers cutting down the forest.
Humboldt was the true pioneer of ecological thinking, the fundamental realization that our planet operates as a delicate, interconnected balance.
So let's bring all this together for the listener. We started with a wealthy Prussian aristocrat who abandoned a cushy desk job to face the brutal extremes of the world.
A man who dragged massive glass instruments through crocodile-infested jungles just to prove two rivers connected.
He invented the concept of human-induced climate change while standing in the mud of a shrinking lake in Venezuela. He bled from the eyes on the slopes of the Andes to explain altitude sickness and map the global dance of temperature and plants.
He initiated a global agricultural revolution with bird guano.
He mapped the continentality of the Russian permafrost, and he fearlessly used raw demographic data to prove that slavery and wealth inequality were fundamentally unsustainable geographical pressures.
And finally, he gifted humanity Cosmos, a poetic and mathematical blueprint of our universe.
He transformed geography. He taught us that geography is never just knowing where things are located on a map.
It is the rigorous, empirical pursuit of understanding why they are there, how they came to be, and most importantly, how they relate to absolutely everything else on the planet.
Which leaves us with a final, lingering question to ponder on your own. Imagine if Alexander von Humboldt were alive today. Imagine him armed not with fragile glass barometers and heavy brass ionometers, but with real-time satellite imaging, global supercomputers, and artificial intelligence capable of tracking billions of data points simultaneously.
It's an incredible thought experiment.
Would those modern tools finally allow him to complete his ultimate vision of a perfectly unified universal science? Or would the sheer, overwhelming, infinite volume of modern data finally fracture his beautiful concept of Zusammenhang, the profound idea that everything ultimately hangs together?
It is a really fascinating question about the limits of human comprehension and whether a single mind can ever truly hold the entire cosmos.
Thank you for taking this deep dive with us. The next time you look at a complex global issue, remember that the X-ray machine doesn't work for the Earth. The waters are muddy and the parts cannot be isolated. But if you have the discipline to look closely enough, you'll see that everything is hanging together.